The other thing, people ask me a lot about Kaggle competitions, right? What Kaggle competitions? Industrial machine learning. Kaggle is fairly genius. If you guys are familiar with Kaggle, it's like a company that does Netflix-style competitions. And I'm friends with those guys. What's funny to me about Kaggle is the data science they do. A lot of it is actually done before the competition begins. What Kaggle is doing is taking a business problem at some company and structuring it and turning it into a data set, like figuring out this is a good classification problem, or this is a good recommendation problem, or whatever, right? They're doing all the hard work up front, and then they're basically parallelizing the machine learning exploration stuff across a whole bunch of people, and then, like paying them some amount of money to do that. But to me, like data science is really, it's the whole path. It's from like, I have a question, I have a mental model of my data, it's data preparation, it's figuring out like what the right analytic technique is, right, all that kind of stuff, and then doing the machine learning. So while I like Kaggle a lot and I participate in competitions and typically lose very badly, and I recommend doing it, just understand that it's just a piece of the puzzle and that a lot of the work has been done for you from the get-go. And that Kaggle is another sort of great educational opportunity to see what is the question this person is trying to answer and what is the data set they came up with to answer it. Okay. Data scientists and Hadoop. Cloud era guy, obviously they talk about Hadoop a little bit, right? Okay, another thing, reference to the California thing about data analysts and data scientists. This is to me the kind of quintessential, the difference between a data analyst and a data scientist. Data analyst says, my tools and data cannot answer a question, and the question doesn't get answered. If I issue a query to the database, the query doesn't come back in like half an hour, I cancel the query, and I go on to the next thing I have to do. That's what happens. Data scientist says, my tools and data cannot answer a question, then I go get better tools and data. And that is fundamentally what it is to be a scientist, right? Scientists design experiments to answer questions. They don't play like, oh, well, I can't think of an experiment to answer this question. I guess I should go ask someone. I should go study something else. It's not really what they do. They keep thinking about it. They keep figuring out ways to answer the questions. Sort of, again, back to the kind of lazy style of relentlessness that I mentioned before. Sort of like ongoing themes in this topic, right? So, very common question. I get asked this all the time. This is obviously a very special audience. This is a San Francisco audience, so this may or may not be appropriate, but we'll go down this path anyway. When should I use Hadoop instead of a relational database? Right? I think of this question, how I answer this in terms of a problem. I call it the unit of analysis problem. And the best way to describe it to people who are very familiar with relational databases is to talk about the things that relational databases are bad at. Okay? Here's sort of the three symptoms of a unit of analysis problem. First symptom, count distinct. You have a star schema in a data warehouse, and you want to know something like how many people in Texas bought a television set from me today for the first time ever, right? Very easy question to ask. Relatively simple English question. Essentially impossible to answer using a relational database in any finite amount of time. The query will take like forever. It's a count distinct query. And star schemas are not optimized for count distinct queries. This is an example. Another great one is, I have a guy who's a friend of mine who studies adverse drug events. His name is Nick Tantanetti. And he wants to know, if I have a patient, I'm looking for patients who are taking a certain drug. And I want to know if they start taking a second drug, like 3 weeks later, in conjunction with the first drug. This is his problem. This is the sort of thing he asks in his data. He has an incredibly difficult time answering it using relational databases. It's just not what we're designed to do. Right? Second symptom, cursors. If you are ever using a database cursor to answer an analytical question, the database has failed you. Something has gone horribly, horribly wrong. Databases are good at filtering things quickly. They're good at aggregating things quickly. They are not good at stepping through things row by row by row by row. Right? This is a bad situation to be in. Okay. Third symptom, this is my favorite. This is like the great nodding question. This is the alter table of data. Every data warehouse in the entire world, the smallest one that's running on my phone right now, it's the one powering Walmart's data centers, has a table in it that you do not alter ever. Because if you alter it, it takes the entire data warehouse down, right? Smiles, nods. See, again, everyone here is on Hadoop, so you guys are like talking about altering. Just use protocol buffers. Why would I have that problem? But no, other people out in the real world, like far off the peninsula, they have this problem. Alter table Hadoop. You can't add a column, you can't change a data type, nothing like that. You just don't touch the thing. Okay. All right. So why is this the unit of analysis problem? The unit of analysis problem is because relational databases and data warehouses are optimized to analyze transactions. That is what they are good at, right? This is really useful. We have solved a bunch of like actual business problems using relational databases. We have solved financial reporting. Financial reporting is solved, not a problem anymore. Enterprise resource planning. How many shoes do I need to have in Sheboygan in 3 months? Basically solved, not a problem anymore, right? Problem is with these other kinds of queries, things where we're asking questions about users, we're asking questions about customers, relational databases are really not ideal for this sort of thing. They weren't designed to analyze questions where you can't squeeze everything you want to know into a single row on the table, right? So if you have something simple, if you have a SKU or like a log message, right? It's got sort of a static set of attributes. It's a relatively flat object, it's just kind of a tuple, right, with a bunch of statically typed fields. It's fairly transient, right? It's just like your SKU shows up, it gets sold to somebody, it's gone. Relational database is the way to go, hands down, problem solved, right? For complex entities though, for things that have hierarchical data structure, for things that have repeated fields, right? For things that have multiple repeated fields, for customers, they have transactions, they have weblog visits, they have friends, they have demographic information. There's all this stuff about these people, and it grows over time. These things get more complicated every passing day as you learn more and more about these things. Relational database isn't really that great. You can do it, it's just not great. And there's going to be a whole bunch of questions you can't really answer in any finite amount of time. All right. So sort of the genius of Hadoop, as I see it, and what is really like most deeply appealing about it to me, people who get it versus people who don't, right? You get it's just a file system at its core. It's just a file system, and that means you get to structure your data however you want. Not the way the relational database says you should, not the way that's optimal for querying, anything like that. You can structure it in a way that is appropriate for the problem you are trying to solve. It's really kind of powerfully cool, awesome thing, right? We have lots of ways of doing that now. We have, like, this problem's been solved multiple times at this point, right? Facebook has Thrift, Google has protocol buffers, and we at Cloudera have Avro, right? The whole idea here is these are just serialized objects that are very easy to evolve over time. So the very first thing I do when I show up on a customer site and we want to start doing some big data analysis is take their transactional data out of their data warehouse and structure it into records that reflect the unit we're trying to analyze, which is usually a customer, but might also be a supplier, it might also be an oil well, it might also be a drug that we're studying or considering for development, right? That's like the very first thing we do. We take advantage of these formats that let us bring in all kinds of new data and analyze it in a way that makes sense. I love this example. I'm going to give a problem example. This is actually kind of doubly appropriate. So spell correction on search engines. You do a search and it does spell correction for you. You guys are familiar with this, right? It's the Drosophila of data science. And this is sort of doubly great because when I was initially querying how to find, this is fruit flies basically for data science. I didn't actually know how to spell it, so I typed in Drosophila, and then it spelled correctly for me, which was kind of cool, right? So I'm about to talk about it. I love this example. This is my favorite data science example. I'll tell you the story with this. The guy who invented Google spell correction is named Noam Shazir. And I think I overlapped in college with him for 1 year. He was a Duke, he was a senior when I was a freshman, okay? Google, Paul Buchheit, you guys know, invented Gmail, invented AdSense, that kind of thing. Friend feed, Facebook, all that good stuff. Interviews, no. And at the time, they didn't really know how to deal with misspelled queries. So Paul's interview question for new candidates was, hey, people misspell queries all the time, and there's sort of weird cases like somebody might type in, United Stats, and that's spelled correctly, but what they really mean is United States, or untied stats, and they mean United States, right? That kind of thing. What do we do about this, right? He asks this as an interview question. It's done it a bunch of times. Ask it to Noam. Noam kind of sits there for a second, he thinks, right? Noam is he was a Putnam guy. You guys know Putnam stuff. Super smart dude. And he says, well, you know what I would do? Is you have all the logs. You have all the records of everybody who's ever done a search in Google. When I misspell a query, which I rarely do because I'm Noam Shazir, I'm really smart. But if I did, what I would do is say, oh, I misspelled my query, that's unfortunate. I'll wait 2 seconds, notice that I misspelled it, retype the query, issue it again, find the result I want, click on it, and go away. So what I would do is I would go through your logs, and I would look at everybody's searches, and I would say, how often, like, find me the queries where somebody issued a query, didn't click on anything, issued a slightly different query 2 seconds later, and then clicked on something and went away. Literally, he does this in his job interview, for God's sake, right? That's crazy. No one's impressed by that? That was really impressive. They had no idea how to solve this problem. The guy solves it in a job interview. So, I mean, clearly he was hired, right? Like, obviously. And that, I mean, obviously Google spell correction stuff is much more complicated today. But that is, to me, the essence of data science. It's thinking about a problem, a business problem, mapping it onto data you have, thinking about behavior or records, like patterns in that data that, like, I guess really, like, thinking about it personally in terms of what would I do? What would the data look like if I exhibited the behavior that I'm interested in studying, right? Looking for that pattern in the data and just counting. This isn't advanced statistics. This isn't machine learning. This is just counting, right? When you have tons of data, you can do very, very simple things and they will work. It's really, really cool. If you haven't had the experience of doing it, I highly recommend it. You don't, like, I'm like not very smart, so I'm super grateful for that fact. All right. Along those lines, those things are very simple. Uncanny Valley. This is if you guys saw the Tron movie, this is Jeff Bridges' character, so this is like kind of fake, younger character. The Uncanny Valley is this idea in animation AI that there's this point where AI will get like just good enough, but like still be kind of off. It'll be like really creepy and weird, and that's kind of where computer graphics is today. So the analogy of that for statisticians is most statisticians who come to Hadoop are used to working with relatively small data sets, and they're used to working with really very advanced techniques. And they're not super familiar with like big O notation. They're not aware of how long things take. They're not aware of like the restrictions MapReduce places on you when you're doing certain kinds of analysis. So if they ask me like, how do I do a gradient boosted model on Hadoop, right? Gradient boosted regression. Very simple to do when you have a single machine, everything's like connected together very fast. Very difficult to do when you have a huge amount of data distributed all over the place, right? It's a little freaky for them at first because it's like, it seems there are all these techniques that are totally fine on a single machine, but now in this new world, there's some stuff you really can't do at all, and there's other stuff that works fine, right? This is an unsettling feeling for them when they first come to Hadoop, right? Because they don't have a strong computer science background to necessarily understand the differences or why these things matter. This is just a challenge I've bumped into a few times in my days. It's useful or not, anyway. Again, I don't know, like, other than like kind of giving them a hug and like saying it's going to be okay, like I don't have a good solution for it right now, but I wanted to make you guys aware of the problem.